Welcome to the Explainer. Today, we are going to unlock the power to ask your data much smarter questions. We're going to completely transform how you write queries, moving way beyond simple requests to some really sophisticated multi-level analysis.
Okay, so let's just dive right into the core challenge here. You've got these massive raw data sets, right? Huge list of employees, sales, orders, the whole shebang. The answers you need are buried in there, but getting them out takes more than just a simple select star. You have to ask the right questions. And to do that, well, we first need to give our data some structure.
And that brings us to level 1, organizing the chaos. Our first big level up is all about bringing some serious order to that sea of raw data. Before we can analyze anything meaningful, like average sales or team performance, we've got to get everything organized into logical, understandable groups.
And the number one tool for this job? It's Group By. Think of it like a digital sorting hat. It takes all the rows that share the same value in a specific column, say a department ID, and bundles them all together. This simple act of grouping is, and I mean this, the absolute foundation for any kind of summary reporting you're ever going to do.
And this little diagram just illustrates that transformation perfectly. You start with this long, messy list of individual employees, then you apply Group By on their department and bam! Suddenly, you have these distinct teams: sales, engineering, HR. The chaos is actually starting to make sense.
Now, what's really cool is how these functions bring your new groups to life. I mean, grouping on its own is just organizing, right? But with aggregate functions, you can start performing calculations on those groups. How many people are in the sales department? What's the average salary over in engineering? Who's the highest paid person in marketing? This is where the real insights start to pop out.
All right, let's level up again. Welcome to level 2, precision filtering. So we've successfully created our groups, we've even calculated some summaries. But what if we only care about some of those groups? Now we need to learn how to filter our results with surgical precision to find exactly what we're looking for.
This is such a critical distinction, and honestly, it's one of the most common trip-ups in SQL. So think of it like this. The where clause is the bouncer at the club door. It decides which individual rows get into the party before they're ever grouped together. But the having clause? That's the VIP host, after the party's already started, deciding which entire groups get to stay based on their summary stats.
And here is a perfect example of that in action. We've already grouped our data and figured out the total employees and average salary for each department. Now with having, we can ask these really complex questions about the results, like show me only the departments with more than 3 employees and an average salary over $60,000. And you can see right there, HR and marketing get kicked out, leaving us with just sales and engineering.
Okay, time for a major leap forward. Welcome to level 3, the query within a query. So far, we've filtered based on fixed values, right? Like more than 3 employees. But what if the number you need to filter by is something you also have to look up in the database? This is where we unlock the incredible power of nesting queries inside each other.
You can just think of a subquery as a box inside of a box. It's a totally complete, self-contained question that runs first to provide one crucial piece of data, maybe a single value or maybe a whole list of values that the main outer query needs to actually finish its job.
And what's absolutely essential to get is the execution order. MySQL is always going to resolve that innermost query first. It gets the answer from that query, and only then does it pass that value up to the outer query so it can do its thing. The main query is basically just sitting there waiting for the inner query to report back with its findings.
Now, what that subquery reports back is key. A scalar subquery returns just one single value, like if you're looking for the single highest salary in the whole company. But a multiple value subquery returns an entire list, like all the product IDs in a certain category. Knowing which one you're working with is going to determine how you write that outer query. And this slide shows a classic, perfect use case. We want all the employees from the sales department, but our employees table only has a depth ID, not the name. No sweat. The inner query runs first, it finds the ID for sales, let's pretend it's 3, and then it just hands that value to the main query. The outer query then basically becomes select name from employees where depth ID equals 3. It's so simple, but unbelievably powerful.
So we've covered the basics, but subqueries can do so much more than just sit inside a where clause. It's time for the boss level, advanced subquery strategies. Let's explore how to use these nested queries in some truly unexpected and powerful places to solve even tougher problems.
Okay, this is a total game changer. Instead of querying a real table, you can actually query the results of another query. So for example, you could have a subquery that calculates the average salary for every department, and then your outer query can select from that temporary derived table to find which department has the highest average. You're literally creating tables on the fly.
Now this leads us to one of the most powerful and sometimes, kind of mind-bending concepts in all of advanced SQL. What if the inner query needed some context from the outer query just to be able to run? And this is the answer, a correlated subquery. It creates the special link between the inner and outer queries. So the inner query doesn't just run once, it runs over and over and over again, once for each and every row being processed by the outer query. This is how you answer those highly specific contextual questions, like finding all the employees who earn more than the average salary for their own specific department.
Now, what's really interesting here is the performance insight. When you just need to know if a relationship exists at all, for example, show me all the customers who have placed at least one order. Exists is your best friend. The in operator would have to build a full list of all the matching orders, but exists, it just checks for the presence of a single row and then stops, which makes it way more efficient for these simple existence checks.
So let's just put it all together. This is the workflow. You start by grouping to organize the chaos. Then you use aggregate functions to summarize those groups. You filter those summarized results with having. And for the really complex multi-part questions, you nest subqueries to connect different pieces of information. Once you master this flow, you move from just pulling data to doing genuine analysis.
And really, that's the ultimate takeaway here. You now have the techniques to group, filter, and nest queries in some incredibly powerful ways. The only limit from here on out is the complexity and the creativity of the questions you can imagine asking your data. So go find those stories.